Hi everyone, this is Miss Wright, and I'm recording this as part of our class conversation on flattening the curve and what that means and why it is important. So, here is an image that basically shows what the entire idea of flattening the curve is. You can see on our y-axis, it's number of cases of coronavirus. On our x-axis, we have the time since the first case. And the entire idea behind flattening the curve and staying at home is to avoid this spike. This line represents the capacity of our healthcare system, meaning how many hospitals do we have? How many doctors do we have? And we want to make sure we don't have everybody get sick all at once, so we go over that limit. Instead, a flattened curve is a bit more prolonged, but always underneath the capacity of our healthcare system. And this is important because countries like Italy are currently in a situation where doctors are having to choose who can they provide care to and who are they going to have to not give care to because they're just way, way, way over capacity. Okay. You may be thinking, well, this is Dallas. This isn't Italy. Why is this important? Okay. I don't know if y'all have seen, but there have been a lot of cases in Dallas. So there was a middle school student in DISD who was just diagnosed. And there are a lot of people who have coronavirus and do not even know. In the past 3 days, there have been 2 coronavirus deaths where the person did not even know that they had it. Okay. Test results confirmed after their death for both this person and a person in Arlington. Okay. So it is really, really important to make sure that we stay at home and try and flatten this curve because way more people have it than we know. So, Washington Post put out this fantastic article that basically shows what happens when people stay home and when they don't stay home. I love these simulations because they really give you a great visual of how important it is to flatten the curve. Okay. So here I'm going to post this article so you'll see it, but we're going to skip to this. Okay. How can let me refresh this run a new simulation. Whoops. Okay. Here we go. Everybody's out in society going about their business. Brown are sick. Blue, the pale blue, are healthy. And you can see very, very quickly, we have this gigantic spike where now pretty much every single person in the population is sick. And then people are slowly recovering, which is purple. Okay. This is with everybody going out about their business. Wow, we have that huge spike. Now, what happens if they try a containment effort where they try and separate the population into distinct sides? Okay. The reason why this is opening is because a forced quarantine, keeping kind of society in two doesn't really work. So you can see still it happens slower, but we still end up at that point where everybody ends up having it. Okay, except for that one little dot right there. Oh, now they got it. Okay. So then what else can we do? Here is what happens when 3/4 of the population are doing social distancing. So you will see 75% of these dots are not moving. They are social distancing. They are not going out and seeing other people. They are staying where they are. And we can see what happens. Okay, we're now at a point where a lot of people have it, but we still have a good number of healthy people. And kind of look at how gradual that curve is. But then, if we really, really do our best, and only an eighth of people are moving, okay? Only an eighth of people are moving. This is everyone is really social distancing like they're supposed to. It takes a long, long time for this to spread. Okay, so I hope that this simulation shows you the importance of social distancing, of what will actually happen if everybody keeps going about their business versus if most of us stay home. Okay, that ended up with only 28 people sick. I hope you can see the importance of social distancing.